All right, today's notes is on 8.2, the reciprocal function family, or I think I titled it in Math Excel, Graphing Reciprocal Functions. I attached a handout because it's all graphing in today's Google Classroom post, or this has been set aside for you to pick up if you wanted that copy of the physical copy and you couldn't print. In your Math Excel assignment, you will only be matching graphs. You won't have to plot any points necessarily. But in taking notes and kind of understanding how these graphs work, it does help to have a place to write this down. All right, so our reciprocal function family is the parent graph would be your 1 over x. All right, we talked about restrictions on x in our last section. So x could never be 0 for that parent function. So what ends up happening when you have a restriction like that is it creates this picture off to the right. If you type that into a graphing calculator or into Desmos, that's what you would see. It creates, they call these branches. So one branch like that keeps going, and then the other branch in kind of opposite corner quadrants. All right, we'll talk about domain and range again with this. So my domain can be any number, but it cannot be 0. My range can be any number, but not 0. So you'll see in those graphs, those curves are never crossing the x or the y axis because we couldn't have that happen. Hopefully it's obvious why x can't be 0. Sometimes students get confused at why y could never be 0. Well, if this is my equation, there's no value of x I could plug in that would make that 1 over x equals 0. So that means y could never be 0. Okay, so we'll have some other vocabulary would be a horizontal and a vertical asymptote. So what an asymptote is going to be a line that you can't cross. Okay, so in our parent function, our vertical asymptote would be the y-axis. So the line the line x equals 0 would be our vertical asymptote. Our horizontal asymptote would be the x-axis. That's where we are never crossing. So that would be the line y equals 0 because it's the value for y on that equation. Okay, so like we've done other graphing and we transform them, we make them a little more challenging. This is that general form. So that A, we've seen that before in quadratics. That A could tell you a stretch, it could tell you a compression, usually we call it instead of shrink, or if it's negative, it could reflect that parent graph. So we're going to look at examples where that happens. The H is the horizontal and vertical that says it horizontal and vertical shifts. It's not vertical. It's just the horizontal shift. The K is the vertical. Oh, I see. Okay. I need to read what this says. It is the horizontal shift with the vertical asymptote. The K is the vertical shift in the horizontal asymptote. Okay, that's okay. All right, so just like we had things like y equals a x minus h squared plus k, if you remember that for quadratics, that shifted things horizontally, that shifted things vertically, same exact thing. Okay, so we're gonna think back to that. All right, so I wanna look at two graphs here. We're gonna make little tables to kind of see how this looks so you can kind of understand how this picture gets created over here. So if I make a little table, I'll make a vertical table because that's what I got room for. And I pick some, this is kind of your typical numbers. Throw those in. So if I throw in -2, I'm doing 1 divided by -2. Right, I'm going to scoot that over. So that's -1/2. When I plug in -1, that's just going to be 1 divided by -1. When I plug in 0, we would say that's undefined because I can't divide by 0, so I can't have a point at 0. Okay, that represents my asymptote. When I plug in 1, I get 1. When I plug in 2, I'd get 1/2. Okay, so at -2, -1/2, -1, -1, we can't go to 0. We've got 1, 1, and then 2 is at 1/2. Okay, so right now you wouldn't really kind of know what's happening. So we'd have to plug in more points. So I want to see what's happening in this area. So if I pick something smaller than 1, like a half, I know I'm going out of order, that's fine. So if I take 1 divided by a half, that means 1 times multiply by the reciprocal, 2 would be my answer. So when I go a half a box, it's up at 2. If you did a third, right, it's going to be at 3. It's going to get bigger and bigger the smaller the fraction that you plug in, because that's in your denominator. So what's happening is that this shoots up really high, but it's never going to cross, because remember, that's your asymptote. Same thing if I would have plugged in -1/2, I would have got -2. Okay, what happens now as I go further down the x-axis? So if I plug in something like 4, that's going to be 1/4. Right? I plug in 5, it'll be at a 5th. I plug in 10, it'll be a 10th. So what happens is it gets closer and closer and closer to that x-axis, but it's never going to cross. Okay. So if you did something like in our next one, 2 over x, this is just going to be a stretch. So what it's going to do is it's going to pull these further away. Okay, so when you're matching a graph, it's just going to get further apart. So a couple quick problems to throw in would be like -2 and +2. 0 is where it's not going to work. That's going to be undefined, and I'll do -1 and +1. So I'm taking 2 divided by -2 is a -1. 2 divided by -1 is -2. 2 divided by 1 is 2. 2 divided by 2 is 1. So -2, -1, -1, -2. We can't do the 0. We have 1, 2, and 2, 1. Okay, you can plug in more points, but they're all going to make the same shape where it gets closer and closer to the x-axis, but it never crosses. Okay, so it just pulled it a little bit further away. So if I have a 3 on top, I'm going to pull a little further away from the origin. If I have a 4, it pulls further away. If I have a 10, even further away. That's what the stretch is going to do, but it still has that same shape. If we look at our next one, now I have a reflection. So that's going to change things just a bit. So if I'm just plugging in a few points to kind of get where it is at and what it kind of looks like here, I usually plug in the number that's on top because that's easy to divide into it. So I'll do a -4 and a +4. And then I always use 1 and -1 because those are easy as a denominator. And then 0, I just like to kind of keep reminding you that we can't cross the x and y axes for these ones. Okay, so if I plug in -4, I'm taking -4 divided by -4, I get +1. When I take -4 divided by -1, I get +4. If I take -4 divided by 1, I get -4. If I take -4 divided by 4, I get -1. So I've got -4, 1, -1, 1, 2, 4. And then I have 1, -4, and 4, -1. All right, so now my branches, right, I've got a 4 in front, so it's stretched, so it's getting further spread out from the origin, okay? And it switched quadrants, right? My first example, 1 and 2, were in quadrants 1 and 3. Now the reflection changes it to quadrants 2 and 4. So most of your problems that you're going to be matching for your graphs, you're going to pay attention to what quadrant it is if it was reflected or not, basically, is what the first few problems will look like. All right, then you're also going to go look at translation, so moving vertically or horizontally. All right, and you'll be asked about domain and range. You'll be asked to write the equations for the horizontal and vertical asymptotes in these situations. So the first thing, well, I'm going to write down all the things we got to find. We got to find the domain. We got to find the range. We got to find the vertical asymptote. And we got to find the horizontal asymptote. Okay. So for my domain, take a look. We've got some stuff in the denominator. I've got, it can be any number, so all real numbers, but what number could x not be? X could not be -1 because that's going to make that 0. Okay? If x cannot be -1, that's telling you what values of x. So here's where -1 is on x. So I'm going to draw in a dashed line. Oops. So that represents my vertical asymptote. That is the line that I can't cross because I can never have any points go through that, because that would mean my x value would be -1. So the line would be x equals -1 for your vertical asymptote. For my range, since there are no values that's going for x that's going to make 1 divided by x plus 1 0, it means I also cannot have y. So I can have any number, but y could never be -2. So I cannot cross -2 as a y value. So I mark that, and then I write the equation for that line, y equals -2 for my horizontal asymptote. All right, so now what's kind of changed basically is that before, all the other graphs before I had these translations were always going around my origin, the center of my graph. Now I kind of have a new center because I just shifted my graph. This went left 1. Remember we did things like this and did these translations, and down 2. So I went left 1 and down 2 from the origin, so I could also see that up there. So if I look at my example number 5 over here, this would tell me right 3 and up 4. So I'm going to go right 3 and up 4. And that's going to be like a new starting location. Or in this case, 1, 2, 3, 4. My horizontal and vertical asymptotes. All right, so they're gonna, when you're matching a graph like this, you're gonna see where the asymptotes are located, and then from there, you're gonna see those branches. So if I was graphing this then by hand, which I guess you'll have to do a little bit on your paper test, I can use the same exact points as I did for 1 over x. I can use all those, but I'm working from here. So we had 1, 1, we had 2 and a half, and 2, -1, -1, -2, -1/2, and -1/2 and -2. I'm using those points right here, but instead of working from 0, 0, I'm working from this new location. And then I've got my branches. Okay. For number 5, I already plotted that. Let's talk about the domain and range. So anything but x could never be 3 because that would make that denominator 0. Range, any number but y could not equal 4. I do not change the sign on that one. It stays the same because it's moving everything up. Okay. Let's see what else. So the vertical asymptote is the line x equals 3. The horizontal asymptote is the line y equals 4. And then from here, just like in my last problem, I've got a 1 on top, so I'll go ahead and use the same exact points in the same pattern. Okay. All right, we're just going to do one more example on this handout. I think I'm going to, yeah, I'll keep this one. There's one more after that, but we're just gonna do this one. So I have, let's just practice the domain, range, vertical asymptote, and horizontal asymptote one more time and graphing those points. All right, domain's gonna come from that denominator. It can be any number but 3, because 3 would make that 0. So I need to mark that as an asymptote on my graph. X can never be 3, so I can't cross that dashed line. So that's my vertical asymptote, the line x equals 3. My range, here's what y can't be. It can be any number but 1. So I need to make a line that shows that can't be 1. And that is my horizontal asymptote, that equation of that line. All right, so my suggestion is to use the y equals 2 over x points that we already made as we look back at this table right here. I would just repeat that table, but I'm working from this kind of as my new origin spot because I moved it right 3 and up 1. So that y is 2 over x table, -1, 1, and 2. All right, 0 would have been my asymptote. So then this was 2 divided by -2 is -1, -2. 2 divided by 1 is 2, and 1. So I'm going -2, -1, -1, -2, 1, 2, 2, 1, and I'm making my branches. Okay, that last problem on here, if you want to look at that, you certainly can. What's going to happen with this one, I can do it real quick. So I have x cannot be -1, y cannot be 0. Okay, and then if I use -3 over x, I would plug in -3 and +3, -1 and +1. So -3 divided by -3 is +1, -3 divided by -1 is +3, and then I have -3 and -1. Okay, so it's reflected and stretched. It's gonna flip what quadrant it's in. And there we go. Domain, anything but x could never equal -1. So that is my vertical asymptote, x equals -1. Range could be any number, but y could never equal 0. So that is my horizontal asymptote, the line y equals 0. Okay, that is it for our lesson. Good luck with your homework.